Hello, programming languages students. Welcome back to another C video. We just covered pointers, and now we're going to cover arrays. Well, the funny thing about that is that arrays are actually just pointers. But the limitations of this and the changes of this are interesting, and looking at how this works and how it operates may help you when you're writing your methods for the assignments. So let's take a dive in. So let's say we create an integer array 5, as shown here, int arr that has 5 elements. We're going to give it the values 5, 4, 3, 2, 1. Well, what actually happens in memory is we create a variable arr, which is, a memory address, and it points to a value of 1004. So the value of arr is just a memory address. And by the way, this is similar to Java. Java does the same thing here. If you've ever tried to create an array in Java and print the array, just system.println arr, you're going to get a weird series of numbers that, as it turns out, is a memory address. So this idea, this concept is the same between the two languages. And in fact, the referencing is the same as in the two languages. If you try to access arr at element 0, you're going to get the number 5. So the real background and the thing that Java hid from you is that arr is just a pointer, points to a piece of memory. Arr at 0 just dereferences that point in memory. So we get the value stored at the address pointed to by arr. And in C, as you go up here, as you square bracket 1, 2, 3, 4, we basically move forward in memory. You'll notice that my example here has 4, 8, 12, 16, 20. There's a reason for this. We're going to cycle back around for it. We'll talk about it near the end of this video series here, this current video. But we dereference it the same way. So ARR0, if you printed it, would print 5. ARR1 would print 4. ARR2 would print 3. ARR3, 2, and ARR4 would print 1. Right, so this works the same way as Java. Behind the scenes, though, there's a couple differences. ARR is just a pointer. That means it's not an object. It doesn't have a length. It doesn't have methods. It just points to an address. So in the above, if you print ARR, you would print 1004. If you print the address of ARR, you would get 1000. If you print the address of ARR at 0, so ampersand, remember, means the address of. Let me wait for this little black box to go away. There we go. Ampersand means address of, so we're on the bottom question here. The address of ARR at 0, well, the address of the value pointed to by ARR at 0 is 1004. So printing ARR prints 1004. The address of ARR at 0 also prints 1004 because 0 just dereferences to the value, and then ampersand references the address of the value. So we're referencing a dereference. Basically does nothing. So star ARR gets you 5. ARR at 0 gets you 5. Both of these end up working. So that's it. That's all there is to arrays. Except there's a couple other interesting points. So let's move along here. What about 2D arrays? In Java, we can have 2D arrays, right? So if arrays are pointers, can we do that in C? We talked about creating an array this way that's empty, creating an array this way that's initialized. What about creating a 2D array? You can do this in Java. Can C handle it? Java handles it because it's objects, and you have objects that hold objects, and that's fine. Well, in C, you can. You can copy the code here and print it out, and then see that this works. We can create an array this way. We can create an array this way, and this is now a 2D array. So how does this actually work? What's the background here? And note that the concepts here are actually pretty much similar to Java. They're a little hidden in the background. There's a few little differences, but the idea is pretty similar. So this just gets you a better idea about what's happening in the background here. And C is all about control and knowing what's happening in the background. So 2D arrays are actually pointers of pointers. So it is a pointer that points to other pointers that then point to arrays. And so that's how it works. So let's say we made a 2D array ARR with 2 rows and 3 columns. And so the first 1D array was basically 1, 2, 3, and the second 1D array is 4, 5, 6. Well, what actually happens Well, we actually create a variable called ARR, and it's stored in memory, and it points to the very first pointer in an array of arrays. So ARR0, ARR1, these are arrays of arrays, which again in C means arrays of pointers or pointers to pointers. So ARR has a value of 1004, which is the address of ARR0, which is a pointer that points to the address of ARR00, which is actually 1. So the very first value passed in is the value of the pointer that also is pointing to another address. So ARR0 would get you an address. ARR00 would get you the value 1. ARR01 gets you the value 2. ARR02 gets you the value 3. Um, and so similarly, we have a second series. So this is one 1D array. ARR1 points to a second 1D array. And so you can dereference it the same way. 1, 0, 1, 1, 1, 2, 4, 5, and 6. So hopefully that makes sense. That's the idea, is that for 2D arrays, the first array just points to pointers that point to arrays, or basically other pointers. Um, and so this chain works. Um, the key is that these two values are consecutive in memory. These these three values are also consecutive in memory. And then the final three values are consecutive in memory, so that the 0, the 1, and the 2 can reference consecutive blocks of memory, and we can still reference and work with things correctly. So hopefully that's clear as mud, but you can make 2D arrays. Now, I'm not going to force you to do too much with 2D arrays. I don't think you'll have to unless you really want to. But it is interesting how this works, and it's pretty consistent across other languages too. But let's actually talk about relevant things for your work as well. So strings. In C, strings are character arrays, which means they're pointers to characters. And so we have, for example, the string I like C. We could initialize this way. So like in Java, if you did string str equals I like Java, well, in C you can do char str array. So an array of characters called str equals I like C. This works. And again, arrays are just pointers. So a character pointer you could also assign. And so this would create a spot in memory for I space like space C period. And then the interesting part is a null character. I've mentioned this before, but it's good to mention again. The convention is in C, every character array or every array should end in a null character. That tells you when the string is done. And FYI, if you look at an ASCII table, the null character itself has to be a value, right? Well, it turns out it's an integer value 0. So the bottom line here, though, is that both strings and string pointers, or I guess str and ptr str, so both of these are actually character pointers and function that way. So the question is there a difference between an int pointer and a character pointer? Is there a difference between an int array and a character array? And the answer is yes. And this gets back to my memory jumping by 4 that I was mentioning before. And so this is, again, a part where C really gets into memory management. In memory, well, it depends on the machine. This may not always be true anymore, but it was originally addressed byte by byte. And in C, characters use 1 byte of memory, but ints use 4 bytes. So if you make a character pointer and you make an int pointer, there are going to be differences when you try to dereference them. So let's take it slow here. Let's say that we have a pointer that is pointing to a character array. So let me flip back a slide for a second here. Let's say we're working with this thing that says I like C. Let's say we're pointing to I like C, one character at a time. Well, a character uses 1 byte, 8 bits of memory. So if I were to do pointer at 0, flip back up for a second. Pointer at 0 is I, pointer at 1 is space, pointer at 2 would be L, and so on, right? So 0 is I, 1 space, 2 L. Let me move on. Well, What's interesting is in memory, these are literally consecutive memory addresses. So it might be address 1000, and then 1001, and then 1002, and then 1003, and each one's a character. However, if I made a pointer array to integers, well, in memory, integers have to actually be 4 bytes because they hold a wider variety of numbers. And so um, if you were trying to reference pointer at 1, same way you would before, instead of being address 1001, it's actually pointing to address 1004. And it knows to do this because when you created PTR, you declared it as an int pointer versus a char pointer. And so if you make an int pointer, it moves 4 per reference, and if you do a char, it moves 1 memory space per reference. Um, you can increment pointers, and they will increment based on the type that they are. So this is a really good series of code for you to copy and paste into a C IDE and see what happens. And this might be a good explanation. So you run this once with int pointer PTR and int I, and then you change it to char star pointer and char I, and then look at the differences. What the increments are going to be different. And the other interesting thing about C is that since these are all they are is just memory addresses and references either up or down in memory, well, you can do -1. There's no limit to this. And that moves you back up a spot in memory. And you can do plus 170, and that moves you down 170 spots in memory, even if you didn't declare it for yourself. And so this allows you to access memory outside of what your array should do, which has a lot of security implications. So um, you'll also see in the slides there's a reference to a string length method. Um, and so this is kind of the part I was getting about with when you create a character array, \0 should be at the end of it so that you can loop through I equals 0 while s at I does not equal our null character. We add 1 to I and then we return it, and that gets us the length of our string. So again, it's a loop that loops until our null character, and that is the end of our array. So rather than doing a for loop for I equals 0, I less than the length of the array, I plus plus, you have to do it this way, where I equals 0. Until the array equals the null character, we just keep rolling. So hopefully this makes sense. This method will be helpful to you in the assignments, so you'll see it in the slides. Please feel free to reference it. And that can get you the length of an array of characters. So hopefully that makes sense. If you have any questions, please let me know, and I'll talk to you next time.